Welcome you all to a new topic on the Numpy Universal function, that is the trigonometric function. First of all, before discussing about the trigonometric functions, we need to know what is a trigonometry. A trigonometry is a Greek word meaning the combinations of values of a triangle with respect to the angle. In a simple words, tri means the tree, gon means the angle, and metry means the measurements. Trigon is nothing but a geometry figure having a three angles, that is a triangle. Triangle and its measurement is termed as a trigonometry. First of all, I am going to discuss it with some sort of equilateral triangle. Here we have the equilateral triangle. Equilateral triangle means a triangle having all sides are equal. A triangle with the same sides is termed as equilateral triangle, because here we have the two, here also we have the two, and here also we have the two. Apart from that, in the equilateral triangle, the angle is always 60 degree. It is always 60 degree. And here we gonna draw a straight angle that is gonna divide this 2 into 1 and 1. And thus we gonna get a half triangle from this full-fledged equilateral triangle. This is a right angle triangle. As we already discussed, here we have the 1, because it is whole 2, I divided this with a perpendicular, therefore we got 1 here, and here 2, and we got here square root of 3 using the Pythagoras theorem. You can just find it out, because root 3 square plus 1 square, and the root is equal to 2. You just google it and you will find out how we can able to find the third side using the Pythagoras theorem. Therefore here we have the 2, here we have the 1, we got root 3 here. And because we have divided this whole triangle using the perpendicular, the whole 60 degree become 30 degree, and this 2 value become 1 value, and we got these 3 values. And you know, the sine of an angle is defined with the ratio of opposite side divided by hypotenuse. This is the hypotenuse. This side is termed as hypotenuse, and this side is termed as opposite. With respect to 60 degree, this is opposite angle. With respect to 30 degree, this is opposite angle. Because we are discussing with respect to the 60 degree, we gonna consider this root 3 as opposite side, and hypotenuse will be this 2. Therefore we got our answer as root 3 by 2. Just write it down. This is the sine of 60 degree. The sine of 60 degree is root 3 by 2. Apart from that, we have the sine 30 degree. I already explained that the 30 degree has root 3 value and 60 degree is with 1 value. And for 30 degree, the opposite side will be 1 and hypotenuse side will be 2. Therefore, when I take sine of 30, this 30, the opposite side will be 1 and the hypotenuse side will be 2. Therefore, we got our value as 1 by 2. This is sine of 30 degree. And we have the 45 degree. Here, our triangle is gonna change, because in previously what we have used for 60 and 30 degree, we have used the value of root 3, 1 and 2. But for 45 degree, this length will be 1 and this length will be 1, because the 45 degree in this 45 degree right angle triangle, the opposite and hypotenuse sides are opposite and adjacent sides are equal. This is opposite and this is adjacent. Therefore we got our value as 1 1, and using the Pythagoras theorem we can able to find this as a root 2. And therefore sine of 45 degree, if we take respect to this, the 45 degree means opposite divided by the hypotenuse. Therefore we got a value as 1 by root 2, and this is sine of 45 degree. After that, we have the sine of 0 degree. When I take this is actually a triangle, but because this is 0 degree, the line, a straight line what we have is submerged over here. As you can find, here we have the thick line and here we have the thin line. Actually here the opposite side is submerged. Therefore we have opposite side equal to 0 and hypotenuse side equal to 1. Therefore 0 by 1 equal to, we got our value as 0. Therefore sine of 0 degree is 0. And we have the sine of 90 degree. When I say 90 degree here, the angle in which we used to take 30, 60 and 45, if we take 90 over here, it will never touch this opposite line. Therefore it will be a straight line, and because it is straight line, the value of this and this will be same, means the hypotenuse side and the opposite side have the same value. Therefore we gonna get the value as 1, and this is sine of angle 90 degree. And we have the cosine. For the cosine, the ratio will be adjacent side divided by hypotenuse. This is adjacent side. If this is angle, then it is the adjacent side, and this is the hypotenuse. For 60 degree, as you can have a look at here, I have took the same ratio 1 root 3 and 2 for 30 and 60. Therefore, for cosine of 60 degree, this will be 1 by 2. 1 by 2. This is cosine of 60 degree. Same with the cosine of 30 degree. This will be root 3 by 2, and for cosine of 45 degree it is 1 by root 2, as you can have a look at here. This is 1, this is root 2. And for cos of 0 degree, the opposite side will be 1, and the hypotenuse side will be 1, therefore we got our value as 1. And for cos of 90 degree it will be 0, as you can have a look at here. This is adjacent side, this is 1, this is 1000. Actually we don't know what is the actual value where both the line are gonna merge together. Therefore we're gonna take it as, actually it is equivalent to infinity. We're gonna take it as some value and we're gonna consider it as 0. And this is the table. Here we have discussed from 0 till 90 degree. Here 0 means sine of 0 is 0, sine of 30 is 1 by 2, and sine of 45 is 1 by root 2, and sine of 60 is root 3 by 2, and sine of 90 is 1. And cos is exactly opposite of this. Here we have 0, here we have 0, here we have 1 by root 1 by 2, here we have 1 by 2, here we have 1 by root 2, 1 by root 2, 3 root 3 by 2, root 3 by 2, and 1 and 1. And actually it is exactly opposite of that, because we're gonna consider opposite and adjacent opposite to each other. And we have the tan is actually ratio of sine to cos. Therefore 0 by 1 we got our value as 0, 1 by 2 and root 3 by 2 we're gonna get 1 by root 3, and in the same manner we're gonna get everything as it is. For example, here we have 1 and here we have 0. 1 by 0 is infinity, therefore we have defined it as not defined value. And here we have the sine, and cosec is 1 by sine. This cosec theta is equivalent to 1 by sine. Therefore we're gonna get 1 by 0 equal to not defined, because we're gonna get the infinity. And 1 upon 1 by 2 is 2, and 1 upon 1 by root 2 is root 2, and 1 upon root 3 by 2 is 2 root 3, and this is 1. You got the the values. And cos theta is 1 by sec theta is 1 by cos theta, and cot theta is 1 by tan theta. In the similar fashion we're gonna get these all the values. Wait a second, we are learning this all things. What is the necessity of this? This has a lot of necessary things to do with the periodic functions. Periodic functions are the same functions through which your signals are designed. The signals that are related to the audio signals, the video signals, the image signals, and we have a lot of signals, and we're gonna process these all things in the machine learning and the data science. Therefore these trigonometric functions play a vital role over there. And this is a particular sine wave. Sine wave starts with a 0 degree. At sine 0 is 0, and sine 90 is actually 1. This is actually 1, and sine 180 is also 0, and we have the sine 270 that is -1, and the sine 360 that is 1. Therefore we're gonna get this as a sine signal. This is cos. For cos 0 it is 1, and cos 90 it is 0, cos 1 it is -1, cos 270 is 1, 0, and cos 360 is 1. Therefore we're gonna get our value as this. Normally all the signals, periodic signals, what we define is in the format of sine or either cos, and the same signals are used in the signal processing, and they play a vital role over there. And we have the cosine transform that is used in the machine learning to find similarities between the two vectors. There also we're gonna use the trigonometric cosine. Therefore they play a vital role. Now we're gonna discuss this using the Google Colab. Now I'm going to discuss about the radian. Radian is another way of representing the angular values. The angular values like 0 degree, 30 degree, 45 and 60, 90 and 180, where every angle represent a different type of orientation. In the same manner, we are also representing the radian. Radian is another way of representing the degree. In the degree, normally we use the the values but in the radian we are using the pi. Normally whenever we came across the circle or circular formulas, we came across the 2 pi r and pi r square, where it represents the circumference and the area. We came across a common term called the pi. as pi is extensively used whenever we are dealing with any circular measurements. In the same manner, radian is also used uses the pi to convert a particular degree into a radian. For example, here we have the values, here we have the radian, here we have the degree. To convert any sort of a degree to radian, we use pi by 180 into degree, and to convert any radian to degree, we use 180 by pi. This is the normal format of representation. Degree is normally used in those measurements in which we have the polygons, like we have the square, we have the triangle, and we have the quadrilateral and hexaheptagons. In such case, we use the degree. But when it comes to representing any degrees with respect to circle, we use the radian, because radian uses a pi. Pi is the ultimate representation of any circular values. Therefore, we use radian. And because we are dealing with signals like a sine, cos in the signal processing or audio processing in the machine learning and the data science, we normally use the radian, because radian gives us values in the pi, and these signals are also represent one or the another way the circular things. And this is about radian and degree. Well, we have discussed about the radian and degrees. By default, the trigonometric ratios that we gonna use in the numpy take the angle in the format of radian. The radian, how we have discussed, in which a degree, when it is multiplied with the pi by 180, we're gonna get the values in the format of radian. And first of all, I will do a conversion from degree to a radian. First of all, I am going to create a NP array that contains the degree 0, 30, 45, 60 and 90. These are some of the degrees that are stored in this particular array. And after that, I am going to use another variable y, in which I am going to assign the degree to degree to radian conversion. First of all, I am going to import the numpy, because I haven't imported any of such np, and import numpy as np. After that, I am going to use np dot we are having the degrees, therefore I am going to write the degree. And after that, I am going to use 2 radian, and I am going to take the values of these x array into this particular y, and I am going to print that y. First, I am going to show what is gonna happen. As you can have a look at here, we have the 0, and to convert any degree to radian, first of all, we need to have a radian variable, to which I am going to assign pi by 180, and into the degree we're gonna get our value as a radian. And after that, if I run this particular thing, like we have the 0 degree, if I add 0 over here, 0 into anything is 0, therefore we're gonna get the radian as 0. I just run this particular thing, and you can able to figure it out how it gonna work. As you can have a look at here, we got our first as 0 degree, then we have 0.523 and 0.785. These are actually the radian what we have generated using the degrees. And we can do the same with using the values from radian to degree. Here first I am going to represent some of the degree. Here I keep it as 0, then I am going to use here pi by 6, and here I am going to use pi by 4, and here I am going to use pi by 3, and after that I am going to use pi by 2. And because these are default from the numpy, therefore I am going to use np. Here also I am going to use np, and here also I am going to use np. And we have successfully created the pi. And after this, I am going to use, wait a second, as you can have a look at here, we have successfully created some gradients and inserted into the array x. And here we have the np dot pi by 6, that means it is a 30 degree, and we have the np dot pi by 4, that is 45, np dot pi by 3, that is 60 degree, and np dot pi by 2, that is 90 degree. And we have successfully created our degrees, our radians. And to convert any radian to degree, we're gonna use radian to degree over here, rather than degree to radian to degree. And I just save it, and I just run this particular program. As you can have a look at here, we're gonna get our values, like here we have the 30, 45, 60 and 90. and this is how we're gonna convert degree to radian and radian to degree. And this is essential part because whatever values we are inserting into the trigonometric ratios is default a radian, and we're gonna get our values in radian itself. Therefore, to convert radian to degree, we use these all functions. Now I'm going to discuss this particular thing with the sine function. Here we have successfully created some of the radians. We have the 0, we have 30, 45 and 60 and 90. Here instead of this radian, yes, I'm going to discuss the sine, cos, tan, these all functions using this particular NP array. I'm going to add 0 over here, and we have the 30, we have the 45, and we have the 60, and we have the 90. We have successfully created an array that contains the radians starting from 0 to 90. And here, instead of using radian to degree, I'm going to use the sine, and I just run this particular program. As you can have a look at here, we got our value. Sine 0 is 0, sine 30 is 1 by 2, therefore we got 0.5, and sine 45 is 1 by root 2. 1 by root 2 value is 0.707, and we have the sine 60, that is root 3 by 2, whose value is equivalent to 0.866. At last we have sine of 90, that is 1, therefore we got our value as 1. And we can do the same using the cos. Here I am going to use cos, and I just run this particular program, and you can get the same values in different format. Sine cos 0 is 1, and the cos 30 is root 3 by 2, and we have the cos 45, that is 1 by root 2, and we have the cos 30 degree, that is 1 by 2, and we have the cos 90, that is equivalent to 0. 6.12 raised to minus 10 raised to minus 17 is equivalent to 0, and same thing over here. And this is how we're gonna go with it. After this, I'm going to discuss using the tan. I just remove this thing, and I'm going to add tan over here, and I just run this particular program, and you can go with these all the values. If you interpret the values what were given in the PPT, you're gonna get these all the values. And this is all about the conversion of the values with respect to trigonometric ratios. Well, using the sum degrees, we have successfully calculated the trigonometric ratios like sine of 90, cos of 90, or tan of 90. What if we can able to get the values of the degree using the values which we have generated? For example, the sine of pi by 2 is equal to 1. What we have generated, can we get the sine inverse of 1 equal to pi by 2? Yes, we can able to get those, and I have generated such function over here. Here we have the values like 0 for sine of 0 degree, 1 by 2 for sine of 30, and we have 1 by root 2, that is sine of 45, and we have root 3 by 2, that is sine of 60 degree, and we have the sine of 90 equal to 1. Now I am going to use sine inverse. Here we have the sine inverse, that is equivalent to arc sine in the numpy. Here I am going to use arc sine of this particular thing. After that, I am going to convert this all the values what we got in the y into the degrees. Therefore, I am going to convert radian to degree, and I am going to pass the values of y, and here we have the z, and I just save it, and I am going to use those, and I just save it, and I just run this particular program. As you can have a look at here, we got a value 0, 30, 45, 60 and 90, and I am going to use cos over here. When I use cos over here and I just run this, and I am going to get 90 till 0, because as I already explained, the sequence is reversed, the sine sequence is reversed in the cos, and this is how we're gonna go with sine inverse of a trigonometric values and trigonometric ratios and the degree to radian conversion. This is about it. Well, do subscribe our channel for regular updates. Thank you.